but for recording purposes, today's matrices past paper questions. Have a little cool slide there. Get started, guys. I will push you in the correct direction in a little while, but I have to give everyone a chance to at least start it up. Now, just one thing. Before you even get started with this question, I know a lot of people are going to do the wrong thing for a squared. A lot of people think that squaring a matrix is a simple process. In other words, I'm just saying, for example, let's say I had the matrix 2, 5, -3, and 6. I'm just saying if. If I ask someone to square that matrix, most students do this. They say, all right, have a square on the outside. I'm just simply going to square everyone in the brackets. I mean, I would do that too if nobody didn't teach me any matrices, right? Naturally, that is what your brain will say. So you will do this. 2 squared is 4. 5 squared is 25. -3 squared, when you square anything in the world, you just get a positive value. So you get 9. And 6 squared is 36. And of course, you leave the exam room thinking you did it correct. That's 100% wrong, eh? This is wrong. To simply square everyone in the brackets, it's wrong. But I will give you a hint. What does squared mean? Like if I have 5 squared, think about what 5 squared means. 5 squared means 5 multiplied by itself. So apply that to a letter now. A squared is really A multiplied by another A. It's A multiplied by itself. Use that hint to figure out A squared plus B. So that's my hint to you. Good luck. I'm giving you 5 minutes to come up with an answer. Send your answers on the chat. What I'm trying to say is this. A squared, right? Forget the plus B part. Anybody can add a matrix. A squared means you're going to take A and multiply by itself, even if it's for a matrix. So A squared really means, isn't this the matrix A? You're going to take the matrix A, 1, 4, -1, 2, and multiply it by itself. And you all have so much practice in multiplying matrix, like a 2 by 2 matrix by another 2 by 2 matrix. That's the one where you split the second one in 2 and Batman swings up to the top and whatnot. You have to go through that whole scenario over here. Now, like I said, you can't expect me to run through back in detail how to multiply a 2 by 2 by another 2 by 2 matrix. So I will just be pushing you in the correct direction, and I will be revealing the answer in a little while. But that's only the A squared part. Once you get the A squared part, add it to which matrix? B. I hope that helps out a little bit. Right? Unfortunately, I've seen a lot of wrong answers for multiplying all the matrices. A lot of people are still multiplying like the 1 by the 1. So you're saying 1 by 1 is 1. It doesn't work like that. Remember, there's a long process to multiplying out the matrices, especially a 2 by 2. Well, by another 2 by 2. The first answer is supposed to be, let me just make sure, 1. It's supposed to be -3. And down here, right? That's our -1 is another -3. Right? Unfortunately, there has been a lot of wrong answers. I'm not too sure why so many people are getting it wrong. Because we spent about 3 weeks on this, right? So I'm pretty surprised. I just double checking my answers here. but you're going to have to work till you get back the answer. But let's let you know, this part is the a squared part. What we have to do now is take the a squared part and add it to the b. So you have minus 3, 12, minus 3, 0. That's the a squared part. And we're going to add it to regular, boring b. Regular, boring b. And when we do that, we will get our final answer here. Minus 1, 3, 2, and 5. Okay? Minus 3 plus minus 1 is minus 4. The addition, you add everyone in the same position. So you add in minus 3 and minus 1. Then you're going to add the 12 and 3, which will give us 15. And then you're going to add the minus 3 and 2. Minus 3 plus 2 is minus 1. And then you have the 0 plus 5 is 5. Right. This here is the final answer. So I've seen a lot, not everyone, but a decent amount of people had the final answer with the minus 4 and the 15 and whatnot. This one here, right, I'll give you a little hint, push you in the correct direction. You have to solve for A and B. Now, there are a couple different ways to do this question, but the way I would advise is, if I'm trying to solve for A and B belong to this matrix, I'm going to keep this matrix, the one with A, B, 3, and 0 on this side, and then I'm going to throw this matrix on the other side. Now, just to refresh your memory, when you throw across a matrix on the other side, it becomes the opposite. The opposite of a matrix is the inverse of a matrix. And also, when you throw across a matrix, it has to jump across exactly one matrix. That will give you an idea of where it lands when it goes on the other side. Okay? Those are my hints. Good luck. All right? It's supposed to be close to finishing, somewhere along the lines of finishing. Now, just to give you an idea, we take in this matrix here, and we throwing it across. Now, when we throw it across, right, it's going to land over here because it must jump across exactly one matrix. So it's going to fall by where the dot is. But the matrix I circled is going to become the opposite. The inverse, right? Anything in maths, when you throw it across, it becomes the inverse. So what I will do, this matrix here, I could probably try to work out the inverse on this side, right? I'll do the working over here because I strapped the space. You all have a whole notebook there. So the first step in finding the inverse is to find the determinant. 1 over the determinant will go here, and then we're doing some switching around in the brackets. But let's find the determinant first. To find the determinant of this matrix, you multiply these two values. So just like I showed you last week, 5 multiplied by 4 minus, you must put that minus, and then you multiply the less important diagonal. Minus 2 multiplied by 1. So 5 by 4 is 20, minus 2 by 1 is minus 2. 2 minus signs touch to give a positive, so you get 22. The determinant is 22, right? So the determinant is 22. Then we switch the more important diagonal. 4 goes here, and 5 goes here. and the less important diagonal doesn't actually move. They just become the opposite. -2 becomes +2, and +1 becomes -1. Okay? Right? That's your inverse, and that will go over here. Right, so let's give you a little bit more, a little, sorry, I'll give everybody a minute again, just to see if they could finish it from there. And also, sorry, Kathy, remember when the fraction is exactly in the middle, like you will have this matrix here, the 12, the -2, the 15, and the 3. And remember, the inverse is going over here. But I showed you last week that when you have an annoying fraction in the middle, it makes life hard. So I had suggested that you drag the 1/22 in front. You're allowed to do that in maths. So what you could do now is concentrate on multiplying these two matrices, which you should be able to do by now. Forget the 1/22. Multiply these two matrices, you will get 4 answers. Divide all of them by 22. Afterwards, after you finish the multiplication, divide everyone in the brackets by 22. And that will, simplify the majority of that side of the equal sign. So I hope those hints help. Good luck, one. All right, so this is what you should at least have so far, right? Clear some space here. Remember, on this side of the equal sign, the only thing that's left on the left-hand side is who? Mr. A, B, 3, and 0. Remember, he's there alone because you threw across the matrix on the other side, so he has no friends on that side. So everybody is concentrating on simplifying this. So let's just simplify this. I'm leaving the 1/22 for last. When you multiply, I'll just call this matrix 1 and matrix 2 for simplicity. When you multiply matrix 1 by matrix 2, we're supposed to get 4 answers. Let me work on getting the 4 answers quickly, right? I'm getting 44 over here, right? I'm getting 66 over here. I'm getting -22 over here. And I'm getting 0 over here. And remember, all of this is equal to A, B, 3, and 0. It's not finished yet, but how many people can verify that you have these 4 values here for me? Raise your hands. 1, 2, 3, and 4, where the dots are. If you don't have those values, you know what to do. Don't give up. Go back through your working and get the answers. A, B, 3, and 0. You have to divide every one inside here by 22 because you have the 22 on the outside. 22 dividing every one by 22 here, right? You're going to get 4 minus 1, 3, and 0. Now, this makes perfect sense. So look at it. You are seeing a similarity between the matrix on the left-hand side and one on the right-hand side. You notice that I have a 3 and a 3 in the same position. So 3 is obviously equal to 3. 0 is obviously equal to 0. So A is equal to what? 4. and B is equal to -1 because they are in the same position. We're finished. We just solved for A and B. A is 4 and B is -1. I don't know what I was thinking. 44 divided by 22 is not 4. What am I thinking? 44 divided by 22 is 2. So that means A is not 4. A is 2. Right? So you guys were actually correct. And of course, if I make a mistake, feel free to say so. Let's take some stress off, right? Let's have a little versus battle here. You all know how the game goes. Two characters are going to be presented on the screen. Vote on one. If you're part of the more popular vote, you get 10 points. If not, 0 points. So let's get the music going. Let's see who's up for the country. Right. Good luck with this one. I don't think this one is as hard as the other one. Just know that the answer you're getting for this one is not a pretty answer. You're not getting a number. You will get an expression for the answer. Right. Good luck and send your answers when you're finished. So let's have a look, well, at least for part A. So for part A, they want you to find what? The determinant of M. Right? We want to find the determinant of M. So let me write it back a little bigger here. The symbol for determinant, as you all know, is the M with the 2 lines here. So that is what we're trying to find. So I'm going to get M here. M is N plus 1, 2 here, 2N, and N. To find the determinant, we multiply the more important diagonal. This here is the more important diagonal. So it's N multiplied by N plus 1. Because remember, you can't write it like this. I suspect some people write it like this. N multiplied by N plus 1. And it didn't put any brackets. Remember, we're taking N and multiplying it by the whole thing here. You have to put it in brackets. That's how you symbolize that you're multiplying the whole thing by something else. Then you do what? Remember the annoying must put what? A minus sign right after. And then you multiply the more important, the less important diagonal. So it's 2 multiplied by 2n, right? Everyone in this brackets gets multiplied by n. N by n is not 2n. I'm watching some people answers, right? N multiplied by n is n squared. And n multiplied by 1 is n. 1 by n. 2 by 2n is 4n. 2 multiplied by 2n. Now this could simplify, right? You have n squared. Remember, n is the same thing as 1n. There's nobody puts in the 1, right? If I have 1n and I minus 4n, and I'll get 3n. That is as simple as part E will get. You cannot minus n from n squared. That's not possible. Okay? So now we finish with part A. We want to do part B. Part B is asking us to find the inverse. To find the inverse of a matrix, whatever you get for the determinant, even if it's crazy looking, usually for the determinant, we get a nice number. Today, we got an expression. We put the expression underneath the 1. That's the rules. The determinant goes underneath 1 when it's time to find the inverse. And then you put your big brackets here. You switch the main diagonal. You switch the main diagonal. So here's n, and here's n plus 1. The other diagonal, the less important one, doesn't move. They just become the opposite. The opposite of 2n is minus 2n. The opposite of 2 is minus 2. Right? That's your answer for part B. How much people could say without a doubt they got it correct without my assistance, without any help from me? Right? I read through as much messages as I can. Right? I know I'm not going to catch all. Right? But once again, right? If you got it wrong, you know what to do. Try to reason out what you. As usual, the class will be uploaded. Simultaneous equations. Now, I know you all could solve simultaneous equations using the regular boring methods like substitution, elimination. But sometimes in the exam, they tell you in writing, it's not even a hint. They say, hey, use a matrices method to solve the simultaneous equations. And of course, you have to use that method. You use any other method, 0 marks. So I want you all to solve this pair of simultaneous equations using matrices. Feel free to turn back in your notes. And of course, you're sending 2 answers, one for X and one for Y. 5 minutes. Good luck. Right? Remember, when you're solving a simultaneous equation using matrices, the X's must come first, the Y's must come second, and the values without any letters on the other side. So this question had no tricks in it, no tricks. You're extracting the values touching the X and Y in the same order. 7, 3. Hope you didn't forget the minus sign by the 5 and the minus sign by the 2. The X comes before Y, so the X goes on top, the Y goes underneath. 6 and minus 5 here. All right? Remember, you want to solve for X and Y, so you have to throw across this matrix. And when you throw it across, it can only jump across one matrix. So that means it will land over here. The small space, it can't really fit there. So it will push around the 6 and the minus 5. Take it from there. When you throw it across, it becomes the inverse. So the X and Y remains on this side. The inverse of this matrix, you have to work out the determinant and do the switching and everything. So the determinant, I'm just working out the determinant on the side here. 7 multiplied by minus 2, that's the more important diagonal. You must put a minus sign. Minus 5 by 3, the less important diagonal. Minus 14 minus 15. Hey, we get a real nice number. 2 minus signs touch to give positive 15. Hey, the determinant is 1. How lucky. Anybody else got the determinant as being 1? Just raise your hands there. Now, if you got 1, that means you're on the right track, which makes things super easy. Because if your determinant is 1, then you put in 1 underneath a 1. And 1 divided by 1 is 1. So that is basically going to boil down to 1. We switch the more important diagonal because we're finding the inverse. The other diagonal, the less important one, doesn't actually move. It just becomes the opposite. Positive 5 minus 3. And you have who waiting on this side here? 6 minus 5. So 1 divided by 1 is 1. 1 multiplied by anything is itself. Well, what I'm trying to say is, whenever I end up with 1 divided by 1, you can just ignore it because 1 divided by 1 is 1. When you multiply anything by 1, it doesn't really change the value. So I would just ignore it. But in the next line, I would just ignore it. But I would write it in here for the example. So now it's just to multiply the red matrix by the 6 minus 5. You do the little thing with Batman swinging up to the top, and you're going to get 2 answers. I will await those 2 answers. The top answer will be X. The underneath answer will be Y. Let's see what I get here. Minus 2 by 6. That's 15. I am getting 3 on top. So that means X is 3 because the top will line up with the top. And t plus, that's the one. It will be t minus, and I'm getting minus 5 underneath. A lot of people need to check back the underneath value, right? I'm double checking it, right? I just make it sure. I've made mistakes in the past. 60 minus this. Yeah, I'm correct. I'm correct. A few people got 65 for the underneath value. Check it back now. Check it back. Check it back. Small mistake. I think it just mixed up the signs a little bit. Not a big error. Not a big error. Right? Moving on in half a minute. So look for your errors, correct it, and of course, if you found the error, let me know now, or raise your hands or something, so I can feel comfortable that you saw your mistake. Try this one. Don't let the words transformations and things get to you, right? Believe me, this question is super doable. I'll just give you some advice. Before matrices can actually, for those who did the homework, right? Remember there was a transformations video to do. I only gave it last week, so I doubt everyone got a chance to do it. Matrices can be used to change coordinates on a graph. For example, I'm sure everyone has done this at a certain point in time. Well, when you have your phone screen, your phone is a computer at the end of the day, right? Let's say you have a picture of a dog, right? That's supposed to be a dog there. Right? Look like a mouse, right? Everyone at some point in time has taken a picture and used their fingers to click or click and drag the picture from one point of the screen to a next point. Everyone has done that. Or you may have taken a picture and you use your phone app, like if you have a face, and you can make it upside down. Everyone has changed a picture somehow. They may have made it bigger using your fingers. You can make a picture bigger on your screen or make it smaller. You have flipped pictures to make it upside down. You have altered a picture somehow. Did you know that your phone screen at the end of the day is a sheet of graph paper? Like, you don't see the X and Y axis in the background, but your phone screen, to do all the calculations, the computer has a graph at the back of in the software simulating a graph paper. So what you're really doing is taking points and dragging it from one point to a next point on the phone screen. In other words, you are changing points on a graph paper at the end of the day. Guess what they use to do those calculations? Matrices. Matrices, you can apply it to points to change its location. So anytime you have a matrix like this, let me say the matrix is -3, 2, 5, and 4. If you take this matrix and multiply it by a certain point, like point D, it will take point D and change the coordinates of D. But one little catch. Whenever you are taking a matrix and multiplying it by a point, you know how a point is? The first one is the x and the second one is the y. When you multiply it by a point, you just have to write the point vertical. So point D, you put the 1 on top and the -3 underneath. The x coordinate goes on top and the y coordinates goes underneath. And you know how to multiply this situation. This is the Batman situation. So when you multiply this matrix by point D, you will get two numbers. Those two numbers will be the new x coordinate and the new y coordinate. So guess what they're asking you to do in part A? They want you to take this matrix, multiply it by point D. Then take this matrix again and multiply it by point E. Then take this matrix again and you multiply by point F. And they're calling the new coordinates of D, E, and F, D prime, E prime, and F prime. That little dash means prime. P-R-I-M-E, like Optimus Prime, prime. You think you all can do part A for me at least? You're doing the same thing 3 times. You're doing the Batman thing 3 times. It's long, but it's easy maths, right? All right. We're going to take the matrix, clean up on top here for you guys. So we're doing part E. So we're going to take the matrix -3, 5, 2, 4, and we're going to multiply by point D. We write in D vertical, 1 - 3. And I'm going to put D on top here so the examiner knows this is me rewriting D. And when we multiply this, we're going to get new coordinates, D prime, because the purpose of taking that matrix and multiplying it by D is to get a new point D. But we can't call it point D because we're changing it now, so we call it D prime. So this is the thing with Batman swings up to the top. And, well, let me write out the rest one time. And I'm going to repeat the procedure. -3, 2, 5, and 4. And we multiply by point E. E is the 4, 2, but we write it vertical. And that will obviously give us E prime. And then we repeat -3, 2, 5, 4. Multiply by, let's say something's blocking my view here, 2. -3. And this is point F, and it will give us F prime. So let's get the new points. I'll use a different color. All right. It'll take me a few seconds to work this out. I get a -9 here and -7 here. I'll double check everything in a little while, but I'll ask how much people got my answers. -8. Okay, 28 here. Getting -12 here. Anybody can agree with my well, 3 answers there in red? Raise your hands if you have the same thing as me. I'm going to check through the chat. All right, so Latisha, you have my first answer. Yep, Amrita, you had my answers. Gideon, you had my answers. Right. I know some of you all are wondering what part B is about. Right, I'll explain part B in a few seconds. Just let everyone correct part A. You all ever made an error on, let me say, you're using the computer, like you're using Microsoft Word, like you're doing an SB, and you make an error and you click the undo button or the Control Z button, and it is erased the error you made? How much people have done that? They press the undo button, or if they made a mistake, right? It's a real common feature. The undo button reverses. It goes back basically in time to before the mistake was made. You're reversing the process. In other words, let's say you move point D to D prime, but you're unhappy about that. So you want to take D prime and move it back to point D. You want to reverse the process. The inverse of a matrix reverses the process. That's an actual realistic use of an inverse. The inverse of, I'll say it again, the inverse of a matrix, when applied to a point, will undo it. It will move it back to the original position. It reverses the process. So if you take the inverse of this matrix and multiply by D prime, you will get back the original point D. So B, if you read it properly, is just asking you to find the inverse of the matrix. They want you to find the inverse of this matrix. And that is the end of the question. They could have easily said, hey, find the inverse of T, matrix T. But they didn't say it easy like that. They said it in a technical way. So quickly find the inverse of matrix T. That's all they want you to do. They don't even want you to apply it to all the points. They just want the matrix that could undo what we just did. So take a few minutes for that and let me know. First step in finding the inverse is to find the determinant as usual, right? I'll find the determinant over here, because I have some space. Multiply the more important diagonal, minus 3 by 4. Must put a minus sign. Multiply the less important diagonal, that's the 2 and the 5. Again, minus 12 minus 10, that's minus 22. Let's double check it. Minus 12 minus 10, right. So whatever you get for the determinant, throw it underneath a 1. Switch the main diagonal, 4 and minus 3 go here. The other diagonal does not move. They just become the opposite. You can leave your answer just like that. You don't have to multiply every one in the brackets by the 1 over 22. Leave it just like that. You'll get full marks in your exam. And if you got that, raise your hands. Don't have too much messages to check at the moment. So you can just raise your hands if you got that for the inverse. Ah, all right, finally. My mouth is getting a break here. Let's see who's next up for the person. I wonder who I put. Green Arrow versus the Punisher. I guess 2 underdog superheroes, but still superheroes nevertheless. Let's see who you all vote for. So we're going to take matrix A, which is 3, 9, minus 2, 8, and multiply by point B, which is P minus 1. And we're going to put this equal to what? 9 and Q. Now, if you're not careful, 9 and a Q could look almost the same in the exam. So for the Q, put a little tail at the end here, right? So you don't mix it up with the number 9. I have seen people just mix that up because they look so similar. So this one here, I'll do it in full because it has some letters in it. The minus 1 is Batman. He swings up to the top. The P and the minus 1 get photocopied here. And the P and the minus 1 get photocopied here. Right? Multiply each pair. P by 3 is 3P. Minus 1 multiplied by 9 is minus 9. Minus 2 by P is minus 2P. 8 multiplied by minus 1 is minus 8. All right. So where can I write this? So the top boils down to 3p minus 9, 3p minus 9, and the underneath boils down to minus 2p plus minus 8. Well, a plus and a minus is a minus. So it boils down to minus 2p minus 8. And this is equal to the other side, which is 9 and q. So when you simplify this side, you end up with one item on top. This is one item, one expression on top and one expression underneath. And on this side, you have one answer on top and one answer underneath. So the top is equal to the top and the underneath is equal to the underneath. So if you didn't finish it, create two equations. 3p minus 9 is equal to 9. You can more than solve for p there. I'll give you some space for those who didn't do it. And the underneath, you could form, well, another equation. Minus 2p minus 8 is equal to q. Now, here's the thing. When you solve for p on top, you could substitute p over here and work it out and get q. Take it from there, right? Everyone should be able to get it out from there, right? Let's start working it out here. You want to solve for p. Throw across minus 9, you will get positive 9. 3p equal 18. So that means p, well, 18 divided by 3, because the 3 I don't need to go through basic stuff like this, right? So p is 6. Now that we know p is 6, we replace that 6 over here. Minus 2, because we now know p is 6, minus 8 is equal to q. We could work out this side and get q. Minus 2 multiplied by 6 is minus 12. You have the minus 8 here. Minus 12 minus 8, bam, minus 20. We're finished, right? At the end of the day, we could say p is 6 and q is minus 20. Right? And a lot of people did send that answer. So that's really encouraging. Right? Look for a mistake.